we need to try and find out if Spacity is able to explain how the different types of galaxies formed. We have come across many types of galaxies, and the classical model of universe is unable to explain because gravity is the basis, and they are unable to explain how these various types of galaxies form. So let us concentrate on only two types of galaxies. Out of the 100 galaxies that you come across in the night sky, 80% of them are spiral galaxies. The rest are elliptical and irregular shape, and they are easy to explain. So once we are able to handle these two, that would take care. And again, this 80% or 75% of the galaxies which are in spiral form, they again are two types. One is without any bar, another is called as barred spiral galaxy. They are almost half, 40% of the galaxies that you see in the open sky are either non-barred spiral galaxy or barred spiral galaxy. But before we move there, it is important for us to understand that the galaxy rotation. So when you have an inner ring and spiral arms, we need to see how the permutation of combination happens between the spiral arms and the inner ring. So whenever you are moving either in an elliptical fashion or circular fashion, the only two options are either clockwise or anti-clockwise. So when you have permutation of combination, both could be clockwise, both could be anti-clockwise, one anti-clockwise, other clockwise. So which one does it happen? We should know that stars in the inner ring and stars in the outer ring have to move in the same direction. If this is clockwise, this also should be clockwise. If it is anti-clockwise, it should be anti-clockwise. So these two are not the possibilities at all. They cannot be spiral arms because they are all formed at simultaneously. So the stars are moving as a mass. So the inner ring is also moving in the same direction as the spiral arm. It is just that they are falling back. Now, why would they be moving this way is because the stars in the spiral arm cannot be seen leaving the galaxy. So we have two types of spiral galaxies. The first one is non-barred type of a spiral galaxy and a barred spiral galaxy. Let us understand how these are formed. Let us first take non-barred spiral galaxy. So the basic three sections of a spiral galaxy are the supermassive black hole in the center, then an inner ring where all the stars are densely packed, and then spiral arms where the stars are sparsely populated. And then we had studied the velocity curve, that the stars in the inner ring, as you move away from the center of the galaxy, the speed of the stars increases, and in spiral arm it is constant. The speed of the stars is constant. So now let us see how Spacity is able to explain this phenomena and how spiral arms are formed. So we have S1, S2 and S3. For the fact that S1 is a holding pressure, it is acting on all the sides of the mass. It does not impart any kinetic energy to it, and since we are discussing all about the speed of the stars, so let us discount for the moment S1 and just concentrate on S2 and S3. So let us see this mass distribution in the galaxy. So you have a supermassive black hole at the center, weighing as much as 40 million suns, and you have an inner ring corresponding to all these blue dots, blue stars. They are densely packed, and then you have spiral arms where we have shown them as gray dots. So let us first consider what is happening to the inner ring. In the inner ring, as you move away from the center of the galaxy, as the radius increases, the cumulative mass corresponding to that particular circumference also increases. As you move away from here, you can see 24, 32, 40, 48. The cumulative mass in that particular circumference increases, and hence S3, which is directly proportional to the mass of the system that it is acting on, also increases. Since this force increases, the speed also increases of the stars as you move from the center of the galaxy towards outside. Now that is how you see this part of the velocity curve, where as you move away from the center of the galaxy, the stars keep traveling faster and faster. Now what happens when we come to spiral arm? In spiral arm you have playout of S3 as well as S2. So let us first see how S3 works out. As you move away in the spiral arms, you will see that the mass remains constant. We have here the cumulative mass corresponding to that particular circumference remains constant, and since again S3, which is directly dependent on the mass in the system, also remains constant, and since S3 remains constant, speed also remains constant. In the sense, the stars, as in the inner ring, were moving faster and faster as you come out of the galaxy. In this case, the speed is remaining constant. Now apart from this S3, there is an S2 also for working out. For S2 you need two masses, one is primary mass, another is the secondary mass. In this particular case, all this inner ring of masses acts as a primary mass, whereas the secondary mass is the spiral arm themselves. So let us see, as you move away in the spiral arms, obviously the distance is increasing, and S2, which is inversely proportional to the distance, also decreases. When S2 is decreasing, so even the speed is also decreasing. It is not the speed which is decreasing, it is an additional speed that it is able to impart is decreasing. So what happens when you have a reduction in speed and constant speed is, when you move away in the spiral arms, the stars have more and more speed, the distance to cover, and hence they keep falling back. If these speeds were increasing just like this, they would also have followed the same way as in the inner ring. But now, since the effect is lesser, so they keep falling back. But the basic speed of all of these masses in the spiral arm is the same as the speed of the stars in the periphery of the inner ring. That is why you see that it is not dropping here, it is the same here. It's only an additional speed which is becoming lesser and lesser. So that is how the spiral arms are formed, or the spiral galaxy is formed.